Here's a probability review. It says which number represents the probability of an event that is likely to occur? Well, likely to occur would just be, very much going to happen. Can't have more than 100%. This is as a decimal. This is 109%. This would be 100%. So that is really likely to occur, like it's going to happen, even more than 81 or 19%. Annabelle buys a ticket for a raffle with several prizes. The probability that she wins a prize is 50%. Which word or phrase describes the probability that Annabelle will win a prize? I would say an equal chance 50-50 because it's a 50% chance. How many different outcomes are there if you flip a coin twice? Well, if you flip a coin twice, the first time you have two things that can happen. You get heads or tails. You flip it a second time. So this is the first time. Here's the second time. You can get heads or tails again. So 2 times 2 is 4. There's 4 outcomes. If you want to think about it, you get heads and a heads, heads and a tails, tails and a heads, or tails and a tails. These are the 4 things that can happen. But I think it's a lot easier if you just think about what can happen each time and multiply, then you don't have to write this out, especially if you get like how many times or what can happen if you flip a coin 17 times. It'd be a lot harder. So just be, 2 times itself 17 times. 2 students, Stella and Ariana, line up one behind the other. How many different ways can they stand in line? So you pick one of them, the first choice. You can either have Stella or Ariana be first, and then you'd have the other one left over, so there's only 2 ways. So really, it's just Stella Ariana or Ariana then Stella. Kind of a dumb question, but in a popular online role-playing game, players can create detailed designs for their characters' costumes or appearance. Ava sets up a website where players can buy and sell these costumes online. Information about the number of people who visited the website and the number of costumes purchased in a single day is listed below. So 419 people bought no costumes, 69 bought exactly one, and 12 bought more than one. Based on these results, express the probability that the next person will purchase no more than one um, as a percent to the nearest whole number. So total amount of people goes on the bottom. So I'm going to figure out what this number is. And then on top, I just want all the people that buy no more than one. So that's the nuns, and that's the people who do one. So this is just 419 plus 69. I'm not going to include the people who bought more than one costume because they don't want that. So doing this, I'll probably just use Desmos. So let's do 419 plus 69, and then over 419 plus 69 plus 12. So it's 0.976. So as a percent to the nearest whole number would be 97.6%, which is about 98%. Daniel has a bag that contains orange chews, cherry chews, and watermelon chews. He performs an experiment. Daniel randomly removes a chew from the bag, records the results, and returns the chew to the bag. Daniel performs the experiment 48 times. The results are shown below. Based on these results, express the probability that the next chew Daniel removes from the bag will be orange or watermelon as a percent to the nearest whole number. So the total amount of times that he did it, or that he got watermelon, was 21 out of 48. So we'll kind of say this is sort of like an experimental thing for watermelon, probability getting watermelon. So 21 out of 48 is 43.75. So it's 43.75%. Nearest whole number would be 44% if I rounded it up. All right. Popular online role-playing game. Again, kind of doing the same thing. Information about the number of people visit the website of costumes purchased in a single day is below. Based on these results, what's the probability the next person will purchase one or more? So I want the people who did one or more than one. So in this one, I'm going to do 105 plus 21 because that's what I want. I want one or more out of everyone. So 105 plus 21 plus 223. That goes on the bottom. So we go parentheses 105 plus 21 divided by 105 plus 21 plus 223. You get 0.361, which is about 36%, the nearest whole number. Mariana is trying to pick out an outfit for the first day of school. She can wear 8 pairs of pants, 3 shirts, 4 sweaters or hoodies, and 4 pairs of shoes. How many different outfits can she have? Technically, she has 4 things to choose from. The first thing is pants. The second thing is t-shirts. Then it's sweaters and hoodies. And then it's shoes. So if I look at it, she has 8 pairs of pants she can choose. And she has 3 t-shirts. Then she has 4 hoodies and 4 pairs of shoes. You just multiply these together to figure out how many choices she has. So 8 times 3 is 24 times 4 times 4. I'm not even going to mess with that. I'm just going to let the calculator do it here. So do 8 times 3 times 4 times 4, 384. How many different possible outcomes are there if you spin 5 spinners labeled red, blue, and yellow? How many different possible outcomes are there if you spin 5 spinners labeled? Oh, so if there's only 3 choices, I guess you'd have to kind of think of it like there's a spinner and it has red, blue, and I guess I'll have to add yellow, right? So the spinner itself, where can it land? But there's 5 of them. So on each one, there's 3 choices on the first one, 3 choices on the next one, 3 on the other one, 3 on the next one, and 3 on the 5th one. This will be the first spinner, the second spinner, third, all the way through the 5th. You multiply these all together. That's 3 to the 5th power, or 3 times 3 times 3 times 3 times 3, I think. 3 raised to the 5th power, 243. 243. And then we'll look here at number 10. In a certain Algebra 2 class of 30 students, 5 of them play basketball and 8 of them play baseball. There are 3 students who play both. What's the probability that a student chosen randomly from the class plays basketball or baseball? So in this one, I'm probably going to make a Venn diagram just to get a picture. I'm a visual learner, and it just doesn't, it's hard to understand what they're saying. So I'm just going to label this circle baseball, like that circle blue. And then I'll make this one pink for basketball. So there's a total of 30 total people. So on the outside, I'm sorry, n equals 30. So I know that everything inside that square total has to add up to 30. 5 total people play basketball. So this whole circle that's in pink has to add up to 5. And then the ones that play basketball, that has to add up to 8. So I have to figure out, they said there's 3 that play both sports. So right here, there's 3 people who play baseball and basketball, but the total of basketball is 5. So that means there's 2 kids who only play basketball but don't play baseball. And then of the 8 baseball players, that means that there's 5 of them that only play baseball. So now you got 5 plus 3, which gives you the 8. And then now you get your 3 plus 2 here, that gives you the 5. But if you add all of these players up together, that's only 10 people. And they said there's 30 people who are there. So you got 20 people on the outside who don't play either. So it says, what's the probability that a student chosen randomly from the class plays basketball or baseball? So that's all of these people, which is 10 out of everyone. So I'm going to do B or B, I guess. We'll do BB or BS for baseball. This will be 0.5 or 50%. If there's a spinner with 14 equal areas, numbered 1 through 14, if a spinner is spun one time, what's the probability that the result is a multiple of 3 or a multiple of 2? So one thing you got to think about is think of all numbers 1 through 14. And then you have to kind of count what would be multiples of 2. Those would be all of the even numbers. So I'm just going to write multiples, and of 2, that would be, I'm counting on my hand, 2, 4, 6, 8, 10, 12, 14. That's 7 numbers. And then multiples of 3 would be, the multiples of 3 would be 3, 6, 9, 12. So that's 5 numbers. Except we have a problem. And the problem is that we counted 2 numbers twice. And some of those numbers are the ones that are multiples of 2 and 3. And those numbers would be 6 and 12. And I can't count them twice. So if I look right now, it looks like I have 12 of them. But I don't actually have 12 of them. I counted 2 of them twice. So I'm going to subtract 2 off of what I have as a total. So really, it's 7 plus 5. And then subtract 2 for the ones for 6 and 12, which I counted in this group and I counted in this group. And then this is out of the total, and the total is out of 14. So I should get 10 out of 14, which is, I guess, if I reduce it, 5 out of 7. And it didn't say that I had to, the probability of multiple of 3 or 2. Sorry, whoops. And I'm just going to leave it as a fraction because it didn't say to make it a decimal. Again, here's another one. We definitely want to make a Venn diagram. What's the probability that a student is chosen that plays both basketball and this? So I'm going to make my box. We'll do basketball, do blue as baseball, and it says there's 13 kids who play neither sport. So out here, there's 13. I know the whole total of everything here has to add up to 30. 15 of them play basketball total, and 5 of them total play baseball. So if there's 13 that are out here, I know 30 minus 13 is what is going to be in the total in here. So 30 minus 13 is 17. So of these 17 players, I have to figure out 15 of them play basketball and 5 of them play baseball. So I could kind of play around here. I could kind of do some guess and check if I wanted. I could see, well, what if you did 3 and then you did 14 for baseball, because I said there's 13 who play neither, 15 play 15 play basketball. Ugh, sorry. So I'm going to play around here. So what I'm going to do is I'm going to say, what if there was like 3 who did both? So if I did that, then there'd be 2 that play basketball. And then on this side for baseball, there's a total of 15 of them. So this would have to be 12. If I add these up, 12 plus 3 plus 2, I get a total of 17, which is oh, sorry, 17, which is what I needed because I need 17 plus 13 to equal a total of 30. So I guessed it right away. All right. If there's a spinner with 12 equal areas, numbered 1 through 12, if the spinner is spun one time, what's the probability that the result is a multiple of 2 and a multiple of 3? All right, so 12 equal areas, 1 through 12. I got to think about multiples of 2 and multiples of 3. So there's going to be 6 multiples of 2, 4 multiples of 3, except we have some that are the same. So if I do 6 plus 4, that's too many. So I got to subtract off the ones that I counted twice. So 2, 4, 6 is a multiple of 3, 8, 10, 12 is a multiple of 3 and 2. And that'll be it. So I gotta subtract off 2 out of the total, which would be 12. So this should be 8 out of 12, or let's see here, they're both divisible by 2. I'm going brain dead here. They're both divisible by 4. So that's 2 over 3, or 0.66. All right, almost done here. In a certain Algebra 2 class of 23 students, 15 of them play basketball, 6 of them play baseball. There's 4 who play both. What's the probability? Again, definitely going to draw Venn diagram. Do baseball, do orange for basketball. So I know there's a total of 23 total people. 4 play both sports. So there's 4 people in the middle. 15 of them play basketball. So that means there has to be 11 that play basketball only to give me a total of my 15. And there's 6 that play baseball. So then there has to be 2 that just play baseball alone. And then adding them all up has to add up to magic 23. So in here, 2 plus 4 is 6, plus 11 is 17. So I'm shy by about 6 of them. So it says, what's the probability that a student from the class plays basketball or baseball? So I'm going to add up all these middle ones, which is 17 out of 23. In a class of students, the following data table summarizes the amount of sleep of students and whether or not they have an A in the class. What's the probability that a student chosen randomly from the class slept 6 hours or less? So I want to figure out how many people are in the class. So I'm going to add all these up. So there's a total of 28 people. I just did that by adding all the numbers. So of the 28, how many of them slept 6 hours or less? So 6 hours or less are all of these people. So that's 2 plus 16 out of everybody. So that's 18 out of 28. Or I could say that that is 9 out of 14. All right. Number 16. In a class of students, the following data table summarizes how many students have a cat or a dog. What's the probability that a student chosen randomly from the class has a dog? So we're going to add up everybody just like we did before. That's 10, 12, 15, 26. So of the 26, how many of them have a dog? There's 12 that have a dog. So that's 12 out of 26. The probability of a dog is 12 out of 26. I could reduce that. They're both divisible by 2, so that'd be 6 out of 13. In a popular online role-playing game, players can create detailed designs from their characters' costumes or appearance. Autumn sets up a website where players can buy and sell these costumes online. Information about the number of people who visited the website and the number of costumes is listed below. If next week she's expecting 1,200 visitors, about how many would you expect to buy exactly one costume? So the people who bought just one costume out of what I did, I'm going to look at what the probability of one costume is. So according to my experiment, or her experiment, there's a total of 5477. So of the 77, 51 bought exactly one costume. So what I'm going to do is I'm going to take my probability, which is 51 out of 77, and I can find the decimal, but I'll just leave it as a fraction, and then multiply that by 1200. And this will give me the expected amount. So in here, we'll do 51 divided by 77, and that's the decimal, but then I'm going to times it by 1200 to figure out how much of them. So about 794.8, but you can't really have 0.8 of a person, so we'd round it up to about 795 people, because that's the nearest whole number. Christian owns a small business selling used books. He knows that in the last week, 25 customers paid cash, 19 used a debit card, and 10 used a credit card. If next week he's expecting 2,000 customers, about how many would you expect to pay with a debit card? So 19 used a debit card out of 19 plus 25, so it's 35 plus 19, which is 54. This is a probability of a debit card being used. So I'm going to take this and then times that by 2,000 to get my expected value. So here we go. 19 divided by 54, bump over, and then times that by 2,000 people, and it's 703.7. So we estimate about 704 people are going to use a debit card. Aaliyah has a bag that contains orange chews, apple chews, and watermelon chews. She performs an experiment. Aaliyah randomly removes a chew from the bag and records the results and returns the chew to the bag. Aaliyah performs the experiment 63 times. The results are shown below. If the experiment is repeated 1,600 more times, about how many times would you expect Aaliyah to remove an apple chew from the bag? So apple's 12 out of the 63 times she did it. And then we're going to say, how many do we think out of the next 1,600 times? And we'll multiply it. Here we go. 12 divided by 63 times 1,600. That's going to be 304.76. So about 305. All right, almost done. Christian volunteers on the weekend at Central Library. He decides to record how many people visit the library, where they go. On Saturday, 4:15 went to the youth wing, 4:37 social issues, 3:23 to fiction and literature. On Sunday, the library had 600 visitors. Based on what Christian has recorded on Saturday, how many people should be expected to go to fiction and literature? So fiction and literature, there was 323 out of the grand total of everybody, which I'm going to have to figure out because they don't tell me. So that's 415 plus 323 plus 437. And then I'm going to take that number times 600. So whatever this is times 600, give me the expected amount. So I got 323 divided by 415 and 437. So I got 415 plus 323. Oops. What is it? 415 plus 323 plus 437. And then take that answer and times that by 600. I get 164.93. or about 165 people. All right, spinners divided into 5 colored sections that are not of equal size, and they're split up in these colors. The spinner is spun several times, and the results are recorded. If the spinner spun 800 more times, about how many times would you expect it to land on red? So the probability of red right now, there's 13 times that it was red out of all the times that it was spun, which is 13 plus 2, which is 15, 31, 38, and then 47. So if you add all these numbers, it should give you 47. So 13 out of 47 times 800 should give me the expected number. I got 13 divided by 47 times 800. I get 221.27. So about 221 times. All right, final stretch. Last 5. In a class of students, the following table summarizes how many students have a cat or a dog. What's the probability a student who has a dog also has a cat? So they're kind of telling you this is given that they have a dog. So it's a probability that somebody has a cat given that they have a dog. So in here, I don't care about everyone in here. I'm just looking at the people who have a dog. So how many people have a dog is 4 plus 2, which is 6. Now, of those people, how many of them also have a cat? Well, 2. So that's 1/3 or 33%. In a class of students, the following data table summarizes how many students play an instrument or a sport. What's the probability that a student who plays a sport also plays an instrument? So it's kind of given that they play a sport. So we're saying instrument, given that they play a sport. So how many people play a sport? I only care about those. There's 7 of them. Of them, 5 of them also play an instrument. So 5 out of 7 is the probability. This is talking about cats or dogs again. What's the probability of the student who has a cat also has a dog? So you're telling me they have a cat. So how many of them have a cat? There's 12. We're saying what's the probability that somebody has a dog given that they have a cat? So out of 12, there's 8 of them that have a dog, or this, if you reduce it, would be 2 over 3, or 66%. 25. In a class of 26 students, 9 are female, and 11 have an A in the class. And there are 11 students who are male and do not have an A in the class. What's the probability that a student chosen randomly from the class has an A? Okay. We're going to skip this one because I don't want to do a one that's just by gender, so don't worry about it. In a class of 21 students, 11 have a cat and 6 have a dog. There's 2 students who have a cat and a dog. What is the probability of a student who does not have a dog has a cat? So I guess I'm going to try to do this. I'm going to say dog, no dog, cat, no cat, or not a cat, sorry. So there's a total of 21 people. 11 have a cat, so if I added up all the cats, that has to add up to 11. And 6 have a dog, so if I added up all the dogs, there's 6. And it says there's 2 students who have a cat and a dog. There's 2 that go in here. So I can easily figure this out now because this needs to be 2 plus 9. This is 2 plus 4. And 11 plus 6. So I'm gonna add up all these numbers, and they have to add up to the total, which is 21. So I got 2 plus 9 is 11, plus 5 is plus 4 is 15. So I need 6 more kids. So 9 plus 6, this should be 15. 6 plus 4 is 10. And hopefully all of this should add up to, these two sides should add up to the grand total, which if you look right here, here's 21 and this is 21. So what's the probability that a student who does not have a dog has a cat? So it's given that they don't have a dog, no dog has a cat. So you're looking at only the people who don't have a dog. So there's a total of 15 of them. So of those 15, there's 9 who have a cat. So that's 9 out of 15, or divisible by 3, that's 3 over 5, or 0.6. Yikes. All right, so good luck, and make sure if you're doing that, try to make it visual, draw a little picture on the side. Good luck.